5, a car is behind a truck going 25 meters per second on a highway. The driver looks for an opportunity to pass, guessing that his car can accelerate at 1 meter per second each second, and he gauges that he can cover the 20 meters length of the truck, plus the 10 meter clear room at the rear of the truck and 10 meters more in front of it. In the oncoming lane, he sees a car approaching, probably also traveling at 25 meters per second. He estimates that the car is about 400 meters away. Should he attempt to pass, give details. Okay, so for this one, the speed of the car relative to the truck, if the truck's moving 25 meters per second and this is behind it, we're going to say that it's going to also 25 meters per second. So therefore, the displacement of the car relative to the truck will be equal to the initial velocity of the car with respect to the truck times time, plus 1/2 the acceleration of the car times time squared. This is what we're trying to, or excuse me, we're trying to figure out from this. We'll find the time, but we'll see here that this is 20, this is 10, this is 10, so this is 40 meters. And this right here would be 0, because he's originally going 25 meters per second, so compare the car, which is also 25 meters per second, is 0. So this will be 1/2 the acceleration, which is 1 meter per second squared times t squared. And so this is going to be the square root of 80 meters, 80 seconds squared equals t squared. And you get 8.9 seconds. That's how long it's going to take to pass. So the question is, in 8.9 seconds, can he do that within the 400 meters? Okay, well, let's figure out how far that car there travels with respect to ground now, not to the truck, but compared to ground. So the displacement of the car with respect to ground would be equal to the initial velocity of the car with respect to ground times the time plus 1/2 the acceleration of the car times t squared. So this would be 25 meters per second, we're given that, times the time of 8.9 seconds, plus 1/2. The acceleration is given as 1 meter per second each second, times the time of 8.9 seconds squared. And when you solve this, you get 262 meters. So it looks like, oh, he can do that for me, 400 meters, no problem. But don't forget, this guy here is moving that direction as well, at 25 meters per second. So we need to figure out how far that car travels, also in that 8.9 seconds, and add it to the 262. So that's just d equals v over t. So delta x will be equal to the velocity of 25 meters per second times 8.9 seconds. And when we do that, we get 222.5 meters. If we combine both of those together, the delta x c respect to ground, the delta x we just found, we get 484.5 meters. That's how much distance he's going to need. We only have 400. So he most definitely should not pass. No pass.